Example problem 3. The Egyptian tomb of Tutankhamun, King Tut, contained many treasures, including 2 trumpets. These trumpets were simple instruments consisting of straight tubes with a mouthpiece at one end and a bell at the other. The smaller of the two was 58 centimeters long and made of silver. This trumpet, like other similar musical instruments, couldn't make a reasonable sound at the fundamental frequency, but it could produce all of the harmonics. What frequencies could the instrument have produced? Well, as we mentioned earlier, we're going to model a trumpet like a tube that is open on one end and closed on the other. We know that the length of the tube, length is equal to 58 centimeters. And what else do we know? Oh, we know that the speed of sound in air is roughly 343 meters per second. Let's put this into SI units. And we want to know the frequencies that this trumpet could produce. Well, using the expression for the fundamental frequency of an open-closed tube, so the general equation is for mode M, the frequency is M times V over 4L. And let's remember that M is equal to 1, 3, 5, and so on. So the fundamental frequency, F1, is equal to 1 times 343 meters per second divided by 4 times 0.58 meters. Now, I wish you guys were here to check my math, but I got 148 hertz for this problem. That's the fundamental frequency. We have many higher frequencies that we can produce. F3 is 3 times the fundamental, or 3 times V over 4L, so that's 3 times F1. Well, that's about, 450, and if you put it in your calculator, you should get 443 hertz, roughly, right? Rounding up. Keep going. If 5 is equal to 5 times the fundamental, that works out to 740. And you can just keep doing this, right? We can go all the way up to the limits of human hearing, but that's, well, it's pretty high. But yeah, let's see, this is 1,036 hertz. Apparently we can hear up to like 20,000 hertz or something like that, a lot. So I'm just going to stop there. But you get the idea. We can just keep finding the frequencies that could exist in this instrument. Now, as we see in the problem doesn't tell us why this is the case, but the fundamental doesn't resonate very well in there. And it could have to do with the material that the trumpet is made of. The fact, that trumpets are usually shaped like this, so the modeling it like an open closed tube is an approximation. So it's possible that for this approximation, the lowest frequency doesn't work here. I honestly don't know the answer to that question. Something for you to find out and let me know. All right, see you later.